All right. So welcome. I see 3 people have joined. I hope you're not the ones being shown on the like 3. But if you're there, welcome. Tell a friend. Tell a friend. We'll be starting in the next 10 or 20 seconds or so. Okay. Nice. Watching from Nairobi, Jill Amonde, I can see you. I think these are Dorcas friends or something. Dorcas gang.
I did. Nice, nice. Thank you so much, wherever you're tuned in from. I see 7 people on. As I said, keep liking. Send this link to a friend. It might just help someone. A few things that we'll discuss here. So I hope you can hear me well. Maybe. Good. So I think the volume is good now. Thank you so much, producer. Good. So Yeah, welcome. I know we've been gone for a minute now. We wanted to come back. But also, we're standing in solidarity with the Gen Zs or Genesis. We do want to, we are just podcasting here and folks are agitating for rights. So, yeah, thanks so much for those who went on the street to fight for Kenyan rights. So, and your civic duty. So, congratulations to you. Now, welcome for this session today. My name is Anthony Nandaa, one of the hosts for this program. We call it Blackboard Live, where we just bring in guests to discuss a number of things, especially people who have who are doing interesting things, to come and talk about what they have done. And mainly, the main reason for this is to inspire others that they can be able to do similar things. So, as I said, if you're on this stream, make sure you're sharing with some friend. Welcome someone else to come along and listen in. Ask questions. We'll have a section for you to be able to ask questions. So make sure you post in your questions early. I can be able to send them to our guest. So first things first, let me do some housekeeping. As always, I've said, once you get us to 1024 subscribers on YouTube, I'll stop doing this segment. Okay, so just help me stop doing this segment by subscribing. We were at around, last time I checked, we were at 545. That was really good. Maybe right now we're already at 46 if someone has already subscribed. So I'll give you today. I'm going to give you 15 minutes for those who are on YouTube or on LinkedIn. Maybe you've forgotten your password for Gmail. I'll give you 15 to reset, and you can go in, log in, and please just subscribe. If you're on LinkedIn, can go to YouTube and subscribe to our channel and come back to LinkedIn if that's possible. So, okay, the 15 minutes is over. So hopefully you've subscribed, and get us to 1024. We'll be really grateful so that this message can go to other people. I'm joined, as always, by my co-host, Habbes or Clement Habinshuti. As I'm always telling you, this is one of the what we call celebrated and critically acclaimed musicians. And that is what he does at night. But during the day, he's a software engineer, also top of the top. Or creme de la creme, software engineer at Microsoft. And I'm really happy that he always joins me as my co-host, and he's doing great things. I wanted also to plug in he has a project coming up, a music project out there, dropping, I think, next Friday or this. I think it should be next Friday. I hope I'm not missing it, Habbes. It's called
23rd.
Yes,
On 23rd. So yeah, next Friday.
Next Friday. Good, we will be there. Okay, nice. And now, also not to forget our producer, Maryann. She's always in the background. You cannot see her, but she's doing a lot of things for us, making sure everything is running smoothly, setting up the stream. Just to thank her so much. So thank you for the good work, Maryann. And now to my guest, or to our guest today, Dorcas. I'll not spoil the intro. I'll let her introduce herself, but I know her for some time now. I think maybe a year or so. We met at Microsoft when she was doing internship then, and now she has come back as a full-time employee. But in between, she's been doing great stuff, especially in the Linux world, the Linux kernel stuff, which I was really amazed about. And I wanted her to come on board and just talk a little bit about what she's been doing, and mainly to just inspire other people. Like, if you thought that this was like something just for the select few, to know that you can actually do it. Yes, it's not easy. It's not that easy, but it's doable. So I'm looking forward to a very great conversation. I'm also learning from her a lot. There was some stuff I was doing, also getting started with Linux kind of development, and I was reaching out to her for some tips. So I'm also today just a student and listener, and I'm really looking forward to this conversation. So welcome so much, Dorcas. And we can just start off by you introducing yourself, just generally, like who are you, and then we can go from there.
Okay. I'm not sure if you can hear me. Are you able to hear me?
Yes. Yes.
Okay. Nice. So my name is Dorcas, and that introduction was interesting. My name is Dorcas Litunya. I'm a software engineer at Microsoft, and I am also a kernel developer. Like, I'm starting now to, I don't know, it's something like I'm now really interested in. So I've been doing that for some time now. And yeah, I enjoy that. Besides that, I like taking walks. And spending time with like my family and friends. So I think that's all. That's the most about me, I think. Yeah.
All right, nice. Yeah, great. I know for the kernel work, we're going to talk a little bit more about it later. So looking forward to that. But before we go to how you got started with kernel development, I wanted to just always I like to know stories of people. Though we always have a short time, but I'm always interested in your journey to tech. Like, what really inspired you to get into this field, and how did you get into? So, just walk us through that journey from where you remember the beginning, maybe whatever first time you ever heard about computers or stuff, and then come up to where we are now.
Yeah. As you said, like time may not be enough because it's like trying to collapse the years and in like 10 minutes, which is almost impossible. But how I would put it is, okay, the first time I heard about computers was, I guess, when I was small, but I was not really interested. I'm not that child who would pick out the radio to fix things. No, I was not those sorts who, like, Clement was that type of person, but now I wasn't that type of person. So for me, I was just like, computers just for playing games, doing Microsoft Word. And at that time there was some sort of chat GPT. I don't know if she was called Eliza. I don't know, I've forgotten her name, but it was not like really chat GPT. It was just someone you could converse with. And I used to enjoy talking with her. Or I don't know. Yeah. So the time that I now got truly interested in this, like, into building stuff, was actually way much later, like in high school, in Form 3. Up until then, I always wanted to be a doctor. So me, I was those doctor children. So I was those people, I normally tell people, after you watch there's this movie for Ben Carson, after you watch that movie, everyone wants to be a doctor. But so I think that's where I got that from. And now when I was 3, in my high school, my physics teacher came and she told us she wanted to start an engineering club. And so I was like, an engineering club? Okay, that's interesting. So I was like, so she told me, I used to do well in physics that time. So I was there. In our school, if you did well in physics, you used to be the person connecting the mic. So public address official, so something like that. So she was like, yeah, I want you to rally up like 50 girls. We're starting an engineering club so that we start to see what engineering entails. So what happened then was we started the engineering club. And so the first event that happened for the engineering club, there was a program that was being run by Safaricom. It's called Technovation. So Technovation is a mentorship program. At that time, it was only for girls between, was it 16 and 18? 16, but now it's like from now 8 years to 17. So that one is like you identify a problem in your community, and then you build a mobile application that solves that problem in your community, right? So for me, I was like, okay, let me just try this. So I started doing the engineering club thing. And so through that engineering club, I now started seeing people who look like me in the engineering field, because how it was structured is that we had mentors who were engineers, so different types of engineers, like software engineers, electrical engineers, civil engineers. And sometimes if someone has not seen someone who looks like them do something, it's like an impossibility. Like you it's not even like in your realm of imagination, right? So so I started seeing female engineers there, and I started wondering, okay, so these people look like me, like we went to the same school, we did the same things, and yeah, they're doing cool stuff. And so for me, I was so fascinated, because the thing was, I could be able to actually solve problems in my society. And so at that time, Technovation had a video, and at the end of the video, they used to say code girls. So I used to wonder, what is this code that they're saying? And so now, when we were told to choose the team name, my teammates and I, we chose a team name to be called Deco. So Deco is like code, but some sort of really like at every 2 syllables you reverse, yeah. So I said, you are Deco girls, we are code girls, but and that time we didn't know what code was. It was just like, that's fascinating. So for me, I'm like, yeah, so I'm learning this thing about solving problems in my community. And it's fascinating that, when I sit at my computer, I can build something that solves problems in my community. And so the first thing was like, what problem am I going to solve? We came up with like some insurance app. So at that time, people used to lose even till now, people lose their phone, all those things. So we were like, we're going to create an app that enables students to ensure that, like, we connect students and insurers, right? So you could build the app, but like there was a lot of regulation around that. But then we did that, we didn't even win, like we didn't even get to anywhere with that app, because people are solving serious problems. But as they're like, we don't want to lose our phones, we don't want to lose our glasses. But it was a start of something new, because now after that I was like, oh, like I've actually solved a problem using technology. So I was really fascinated. And so I came home, I told everyone in my family, I no longer want to be a doctor, I'm going to be an engineer. And so, because at that time, I only used to think that doctors are the only people who help people. But now, if I'm an engineer, I'm powerful. Like I can help anyone to solve anything. So I went home, changed. There was that mindset shift. So I was like, yeah, this is what I'm going to do. And after seeing people who look like me in the field, I was like, yeah, this is what I'm going to do. So when I finished Form 4, I was now done with Form 4, and my sister was like, she was like, yeah, Dorcas, you can't sit here. You're not going to do ICDL, because that time when you finish Form 4, it's like computer packages or ICDL or something. So I was like, no, since you told me you did Technovation, what you're going to do is you're going to do programming. So I'm like, okay, I'm going to do programming. She's like, yeah, you're going to do websites. You're going to learn how to do that. I'm like, but I didn't do computer in high school. I didn't do computer studies. So I'm like, I didn't do computer studies. I don't know anything about that. She was like, it's okay. You're just going to go and learn, because she was like, the way I see it, you're really interested in this, and if you don't start on that track, you might like lose interest, like you might waste whatever the zeal that you have. So I was like, yeah, then that's okay. So I don't come from Nairobi, so I come from Machakos. So it was like, you now go to Nairobi, go look for a school, and now start doing programming. So I came to Nairobi, looked for a school, and that's what I did. I started doing website programming. And so I was not understanding those things. I remember that time I was there. I mean, the most complicated thing for me that time was to understand what an array was. I'm like, hey, what is an array? I'm like, hey, thing is difficult. And so my sister is just there telling me it's okay. You may not always get it on your first try. And she was also telling me, hey, Dori, when you come to campus, everyone comes with a skill. Everyone comes with a skill. People come when my classmates. So she also trained in electrical engineering, what I ended up training. So my classmates, they came here, they were building websites, they were building mobile apps, and she was like, I want you to be that classmate. I'm like, hey, okay, but this thing is so I finished, like, it was just a short course after Form 4. So I just did it for like, I think 3 months, went back home to Machakos, then I enrolled for my degree. So I did a degree in electrical and electronics engineering in JQuat. So when I was joining JQuat, I started my degree, and I continued with it over the long holidays. So every year in JKUAT you have long holidays. My sister was like, okay, you didn't understand programming, the problem is the school, so get another school and then now read from there. So again, I went to a different school over my long holiday, and that time I started making sense of everything. Maybe the problem was the school, I don't know, but also probably I was also young and not so.
This time.
So yeah, I started learning programming. That was now past year holiday. And then from there on, it just became a habit. Like I just now started practicing on my own, started watching YouTube. And so where is this story supposed to end? Is it supposed to end now? Or
I think when you started, at least the journey, I think we can see the journey that you. But one thing, actually, I think you've covered it well, because
yeah,
that's you get into you. So what are you doing? Mechatronics or
electrical and electronics engineering. Yeah.
oh, okay, nice. So wait, you did for the 5 years, right?
Yes, I did it, and it's actually one of the reasons why I ended up like in the kernel. So
Ah.
that's yeah. So should I continue with the story, or I don't know?
Yeah, no, actually, that could be a good segue. You can take us to really how did you get to hear about the disk kernel development, and how did you get started?
Yeah.
Yeah.
So that time, that was in my first year. So first year is when I went to and I started building like websites, like now full on websites. I was like website developer, and in school, I mean, we used to have some time in the evenings and also on weekends. So I used to volunteer. There used to be organizations that used to come to get campus students to teach kids how to code, and so that's what I do also in my free time. So my free time I'd do that, and then go to class and stuff. So there was this one time, it was during now COVID. So we were running a kids program, and so there was a track for IoT. I was there, and so this person kept talking about when we're going to be using C to do Arduino, da 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 da, and then he was speaking so many complex things, and then I was like, what? And then he was like, this is so I'm like, what is this person saying? And so I was like so fascinated, because how he was speaking about it was like we're going to program hardware to talk to software, and for me I'm like, that's really interesting. So now in COVID, our schools were closed, so schools were totally closed. And I was like, okay, so I was like, and that time everyone was giving free courses, like Udemy was free, Coursera was free, everyone was like, it's the end of the world, so like, let's do everything free. So this person had spoken about something I didn't know, like I just knew to do websites development and all that. So I applied for a scholarship for Udemy. I got a scholarship, and so I now started building, and it was a scholarship, so you could do any course on Udemy. So I chose to do C. So, and that's how C became my first programming language. So I did the course on Udemy, full end to end. So there was a beginner course and there was an advanced course, right? So I did the full course from Udemy, so end to end, did all the projects. So it used how it was structured, like there were videos and then small projects, videos and then small projects. And so by the end of the course, I was pretty proficient in C. So we went back to school. Now after COVID was over, when we went back to school, I was really good at C, to the point, like now, sometimes like our lecturer, now in Tripoli, normally the first programming language is actually C. And so by the time we were taking that class, like I knew so much. And now the lecturer was not. So I was now teaching these other people. I'm telling her, this is what you do, So I was literally living my sister's dream. She was saying people come here with different. So that's what happened. And so I became very good at C, and it was very fascinating for me. And then now what happened now, Microsoft advertised their internships, and my sister was like, I've never had anyone do data structures in C. And I told her, now this is the only language that I know, so there's no way I can do it and the thing about learning C is that after that, like, nothing is, you can pick up anything. Okay, in most but like because you see, most of these are like have a lot of abstractions, so like you don't think about a lot of the things that like it's mostly like you have classes, you have everything like well defined for you. But with C, if you want to do something, it's like you're starting from scratch. So she was like, just get an OOP language, do it, and then after that, if you want to continue with C. So the closest to C was Java. So I was just like, let me do that. Did the interviews with Java, because picking up Java from C is not even difficult. It's just like now there are classes and that's it. So was able to do the data structure thing, got into the internship there. But then now in fourth, this was now the internship at Microsoft, right? So in Triple E, again, there's a course we do. It's in microprocessors. So it's mostly like talking about computer architecture. So we talk about memory organization, we talk about scheduling, we talk about like literally how the microprocessor is organized. And that course was so fascinating for me. It was so fascinating. We were talking about the microprocessor we were talking about then was 8086. I don't even use right now. It's like just like the most basic. So we were talking about 8086, and it was so fascinating. For me, it was like, right now we have the computer here, and we have like all this hardware abstracted. Like we don't know how they communicate. We don't know how RAM works, how ROM works, all those things. So for me, I was like, hey, I'm truly enjoying this. And in my mind, like when I enjoy something, I'm like, I'd want to pursue this. So I now started looking out for how can I be able to I've done my training, my degree in electrical engineering. I know a lot of things about hardware, and I've also been doing these things about software. Is there a way that I can be able to mesh these two things together? Because I tell people, I really love education. So for me, I'm those people, okay, I've already spent 5 years here. I don't want to waste the knowledge that I've gotten in my 5 years here. So I'm like, how can I be able to mesh these two together? And so now that's when I now started looking out for like operating systems things, like, okay, this looks like an interesting area. Because like for me, microprocessors was that part for interfacing the two. Because in microprocessors, what we are learning then was assembly. So we're now like at memory level. So we are doing assembly, did you move this, and the addresses, those things, right? So I'm like, yeah, this looks like integrating software and hardware. So is there a way I could do this? And so when I started to look around, the closest way to do this was now through operating systems. And now I started researching, okay, how can I be able to get into operating systems? And then that's now how I came into the kernel mentorship. Oh, in between, like in campus, was also part of another mentorship group called Kamilimu. So there were people who were applying to Outreachy, which I'll speak about later. And so I just went to that program site and I saw, you see, opportunities in Kenya for these things are very limited because I don't know, we don't even, I didn't know anyone who did that. So I was like, okay. So now when I went to Outreachy, it had very niche things. So, you could be a contributor at Git. I'm like, oh, we normally use Git, tumezoea Git push, Git pull. But now there are a lot of things that happen behind. So that ukiandika hapo, Git push it works. Oh, sorry, maybe there's an international audience. So it works as Git push. So when I went to the Outreachy website, right, I was able to see there was like Git and there was like the kernel, and I was like, yeah, I want to contribute to the kernel. And then that's now how I ended up. It was mostly, I'd say, to summarize, it was mostly because I was pretty interested in meshing hardware and software. And so I was looking for something to apply that to. And so that led me to a journey of many things. And now through at least Kamilimu, that gave me exposure. Because, sometimes you want to do something, but then you don't know where these opportunities are at. So like, you were just like helpless. So I think that was a link so that I got to know about Outreachy. And then after doing now Outreachy, I don't know, that's how I knew about the kernel. And I started now, because actually that time I contributed to 2 projects. I contributed both to the kernel and both to Git, because Git is also open source. So yeah, we were doing, there was a command, they were trying to make a new command, so I was also doing that. And the other thing was, I also had knowledge of C, but then I had not seen any job that was advertised for C. So in my mind, I'm like, I have all this knowledge. Like, I know how to use malloc. I know how to do these things. I can allocate memory. I can deallocate memory. I know how to clean up my things, but I'm not using this knowledge. So it's like becoming redundant, like, things like that. So yeah, I guess the long and short of why I got interested in the kernel is I had knowledge that I was not using, and I want to use that knowledge. Yeah.
Okay, if you could just take us back a little bit to how was the I know you've just finished the internship like a month ago, right?
No, like 4 months ago, actually. Like, it's just what happened a month ago was my contributions being merged to the mainline kernel, because that takes a while, because you see.
Yeah.
Yeah.
Okay. Oh, so okay, that's interesting. So you started off your internship around that must have been around
December. I started in December. So now let me tell you. You see, I knew C, I knew assembly, I knew those things. But when I went to the kernel, those people are, as you say, those are the select few. I mean, I had worked with and people who are intelligent, like you guys are intelligent. Everyone, like, at Microsoft. And then now I went to the kernel and I'm like, this is another level. So my first commits, I was just being told, like, someone would ask you. So the thing about the kernel, people there are a bit, sometimes people can be brutal, How could ask you, like, why would I do something like this? Someone, you'd write code, like, you spend like the whole night thinking about something. Someone tells you, this makes no sense. I'm like, and like, that's like literally your best work. You've put your best work there. And so you're being told that. So my mentor kept telling me, saying, Chichi, you're also paired with a mentor, right? So my mentor kept telling me, you have to be resilient. Like, don't take these things personally, because in Kenya, I'd say, and also it's like a thing about working across geographical regions. In Kenya, we are a bit passive aggressive. Like, someone, you might be doing a bad job, but someone will not tell you, hey, this job is bad. Unajaribu, so something like that, like, you're trying, something like that. And so we have a way to say things not so direct. But now in the kernel, people are direct. Like, no one has time to waste. So if your code is bad, you'll just be told this code is garbage. Like, what are you saying? So now in December, that was what was happening. I was being told that my code was not good code. So so that's what I was being told, and now just learning from that, being able to improve on that, because it was like feedback. And so it was a good time for me, because it was important for me, because I was able to learn how to separate like my work from like me, because like that was my work. It does not mean that I am a bad programmer or whatever. It was just that work was bad. And now, like 4 months down the line, I look at it, I'm like, what was I doing? So another thing also, between December and June, it's because ramping up on the kernel is also difficult. Not difficult, really, it's interesting. Because I have to, because I really want more people to contribute to the kernel, so that you see how, because I guess that is the main aim of this talk. What I'm saying is how it's connected, like it's interconnected. So it's like the operating system. So, to learn what that means and to learn how hardware talks to software takes some time, because if it's something that you've not worked on ever in your life, like you've not done that, you have to take that time to ramp up on it. And so you have to read a lot of resources. You have to know now you have to know like there's this software layer and then there's this hardware layer, but then there are things that communicate in between. So we have the drivers in between, and now how all these three work together. So when you're working on there was that. So ramping up on that, and then now being able to do my first patch is like a git commit. It's like a commit, and then like when you do git commit, what happens behind the scenes? It's like how patches work. Because at that time, like Amanda kept telling me, I think Git uses like patch utility behind the scenes. So he kind of explained that thing there. But at that time, I was very stressed because of the things that were happening in the kernel. But then that's what happened. And then so did my commits, submitted in around April. And then in June, that's when they were now being merged to the now Linux Torvalds, who is like the creator of Linux and Git also. That was when they were merging the two. Now, my code is now being used in the latest Linux. I think that's the best way.
That must have been, is it a 6.11?
Yes, 6.11. So it was merged on 6.10. So it was merged on version 6.10.
Ah, okay, nice. So by the way, so for guys who are just maybe because I see we still have some time. I wanted us to just break it down to like, actually you're the one who sent me Outreach's site, and then they have a page on Linux newbies. Is it Linux newbies or Linux for newbies?
Kernel newbies.
Kernel newbies. So I think I'm gonna add all those links here. Actually, do you have access to the chat? Can you see what people
have? I don't have access to the chat.
Oh, okay, no worries. So I'm gonna send those links on the chat here, and also I'll pin them on the as comments on this stream on YouTube, so you can be able to look at that. And I know Cornelius was asking whether this was being recorded. Yes, it's being recorded. You can be able to play it back. But then there are some comments here about some of your, I think, classmates who are saying you did a good job connecting the microphones. And shout out to Kamilimu. I think you got to know about Outreach through Kamilimu.
Yes.
Kamilimu is really doing a great job. I keep hearing a lot of good things from through like the alumni of Kamilimu. So yeah, just shout out to them. Good stuff. So I wanted us to break it down to like if I'm today, and mainly this is just, I think any engineer who is aspiring to just try hard things or try things that are challenging to them, and they can be able to, because with the kernel, when your contribution is affecting so many, because for example, yours went to 6.10, it means all like whoever is using Fedora, Ubuntu, mention any Linux variant, so long as they will be using that 6.10, which most likely will be in their next version, they'll be using your work.
Yeah.
So you get to see like the impact of your work at a bigger scale, like even the phones are using the Linux kernel.
Yeah.
So the Android phones. So I wanted you to just break down for anyone like listening in where the best way they can get started. I know you've mentioned C. There's no negotiation about that. I know Rust is being added, but it's not yet like still experimental.
Yeah.
But C still, I think it's gonna take maybe another 10 years, maybe before maybe Rust.
Even like 20, because the opposition I'm seeing in my subsystem, like everyone is like, no, we don't want Rust. Like you see now, us like the kernel has interesting people, because like the developers the maintainers, so each subsystem, so the kernel is divided in subsystems. So there's media subsystem, there's networking subsystem, there's graphics, there's drivers, all those subsystems. So so each subsystem, because you see it's open source, but there has to be someone who is in charge of checking the quality of the code before it gets to Linux, right? So the maintainers are like people who've been in the kernel for 40 years, 30 years, So now they know the ins and outs. So to transition something small takes a really long time. So like I guess with Rust, it will take like to say that now we are changing the entire of the kernel, it's difficult because, like, for example, I was in the media subsystem. So we were moving from one version to another version, and we're just seeing a thread. It took like 15 years to do that. So, like, to move from version 1 to version 2, it took that. And it was now the people maintainers doing that. So, you can imagine if it's now rewriting an entire thing. But I don't know. I don't know how it's going to go because, with tech right now, you can't predict. So, yeah.
So we can assume that the best thing to start off is get a good grasp of C, right? So say that would be like step number 1, learn C. And someone was asking which you mentioned Udemy, but if possible, so you can send us the link. But then maybe you can put on the private chat if it's possible. Then I'll move it to the main chat, or the producer will move it there. So the links, the Udemy course, and of course the other book. If you like books, I think a good book for C is it's called the C programming language. Is the
founders of the language, actually.
Yeah. The guys who wrote the language and they also wrote the book. So it's a good one. I've read it, and it's I think it's around 200 and something pages. So C, by the C itself, is a very small language. Of course, they added a few things later on in the other versions, but the original, what we call K and RC, has only, you can't believe by anyone who's listening, it has only 32 keywords. Can you imagine a language with only 32 keywords? But of course, now there are more other keywords after the new variants, but there's no like really much difference from those 32. So yeah, C is the first thing. But now take it from there. Like the next, after you've known C, what are good places to get started, and tips on how to get started?
Yeah, that's an interesting question, right? So after you've been able to ramp up on C, make sure you have a good grasp. So I've sent the link, and then there's the beginner course and there's the advanced, but this beginner course is also like pretty good. After that, it's easy. The other way, there are 2 paths someone can follow. If you are a student, and then if like you're a professional, right? So if you are a student, there are programs that are tailored for students to be able to learn how to contribute to open source. One such program is Outreachy. So Outreach is actually for both students and unemployed people. So if you fall in those people, you can do Outreachy. And actually all these programs are paid programs. So you'll not be actually doing for free, like no one is giving you money. No. Nice. So Outreach is for underrepresented groups in society. And then there's another one, which is, I had like something that I wrote those things here. So there was that. So Outreach is for that. There's another one called EXOG, Endless Vacation of Code. Let me just send that also in the chat.
So I never heard about that.
That is for students also. So they have like projects there, and then you learn how to contribute. So I'd say with the kernel, you actually need a mentor to be able to know how to navigate through, because doing it by yourself is a bit tricky, because there are a lot of things that happen before like your code gets accepted. Like you need a lot of perseverance if you're doing it alone. But now you have people guiding you, you can be able to ramp up fast. You can be able to know, because you see, like when people send their first patches, you do know this is a first patch, because someone sent something and you're like, hey, why are you sending this? So, and as someone is just trying, and if you are like me, you are not ready to be told this code is bad or something like that. So there's that. So this is for students. EXOG is actually for students only. So they have projects there. And then the other one for people now who are working or looking to transition, there's one called Igalia Coding Experience. Yeah, it is. So that one, Igalia is I don't know, it's not even an organization. It's a company, not even a company. just look it up, read about Igalia. So there's that, you can do that. And then another way to actually start contributing to the kernel, for those people who are electronics enthusiasts, like those people who use Raspberry Pi, those people who use Arduino, all those things. If you have hardware that you want to, like you have hardware, like a chip or something that is not working with your board, you can actually write driver code for that. So for you to be able to write driver code, there's a driver API that specifies how driver code should be written. So if you have that, you have both hardwares, and then you have the data sheet of the driver. So I guess this is leaning so much towards engineers, like, but even someone, if you're just a hobbyist and you know those things, you can be able to do that and then try to contribute to driver. Another very good way for anyone who wants to also contribute to the kernel is through the Linux Foundation mentorship. And I'm putting it here. So the official mentorship for Linux Foundation, I've put it there. And then the last way to do it, I guess most people have had it, is through the Google Summer of Code. That one is for students and also anyone getting started with the kernel. And I'm seeing Clement is asking, if someone is interested in kernel contribution, can you be a mentor? Clement, can you clarify your question?
Can you be a like? I think he's asking. Clement, come up. Yeah. Sure.
What I mean is, since you said like to someone to contribute to the kernel, it's good if they have someone to mentor them. So I was wondering, like, if someone is interested, and since you, Dorcas, has some experience or has the experience and have gone through the process, would you be in a position to mentor someone?
It depends, because my experience is in a very particular subsystem. So me, I'm in the media subsystem. If they want to do that, if they come to the media subsystem, I can help them to ramp up and all those. But then these programs have like the maintainers, and now most maintainers actually mentors, because they want people to come to the kernel, like they want people to contribute to the kernel so that the kernel continues to live. If you're just getting started, I can give you the tips on how to get started, all those things. But then you have to find an area that you're interested in, because as I said, it requires a lot of perseverance. So I don't want to force you down to the media subsystem, but maybe you have a driver there that you want to program. So you have to know the area that you're interested in, go to the mailing list, because everything about the kernel is open source, so you can find it literally anywhere, right? So go to the mailing list, subscribe to the mailing list, look at the mailing list, just study it to see who's who in that mailing list, and then try to start sending contributions. And then there's kernel newbies. I think Nandaa should share that here. I don't have the link to that. That helps you know how to write a patch, because there's a way to write a patch, there's a way to respond to the emails in the kernel. Another way I would say is, after you've been able to do that, now with these programs here that I've shared, those ones, if you don't know anything, like if you're 0, if you start there, you'll be okay, because the mentors take time to help you go through that. But now if you want to start on your own, you can just start on Kernel Newbies and then look at the projects that you're interested in and just start contributing there. There's something else I wanted to say, but I have forgotten.
It's all good. No. If you remember, yeah. But I think you've mentioned GSOC. I think Google Summer of Code. I wanted to show the links, just if anyone is just watching and not looking at the chat. But the links are all the links on the chat. And also, by the way, I just went and pulled your contributions, so I've linked them there. But I know you always a blog post.
Yes, I've been so busy on board. But yes,
no worries. Once you're done, I think if you're really interested, you can check out also a blog post by Dorcas is coming up soon on just her experience doing those 2 patches. By the way, let me just give a small story of myself. I have one pending contribution that is yet to, but it's just one character change. It's just a change from Python to Python 3. Just adding the 3, and it is it's taken like months. So you just have to be patient. And then, as you said, it's without a mentor, it's really hard, and I can tell. I can actually even tell from my own trials, and I think if you're a student and you can get hold of those programs, they'll really be great. I would really love to hear more and more of folks doing kernel stuff. So, and by the way, if you're out there, you're in Kenya or within African region, and you're doing kernel development, let me know. I really want to link up with such folks. Can come on board, talk about the story. It also inspires others. I think we are getting. I love the trajectory that you are taking. That things that we wouldn't hear anyone doing kind of stuff like maybe 5 years ago, or maybe even in Africa, or let me say in Kenya. And now we can see people like Dorcas are doing this. I think it's so encouraging. I can't wait to see like what happens in the next like other 5 years to come. So really good stuff. Yeah. So Clement, do you have any follow-up questions? I don't know. This is the time when time starts flying.
Yeah, okay. I'm interested to learn more about like the actual experience from contributing. Especially maybe our first question will be: you said like you had learned C through like tutorials and Udemy and your own personal like maybe projects, and then now you transition to using C to writing C in a large production code base maintained by thousands of people. And usually there's usually a huge difference between like writing stuff, personal projects, and doing things in production. There are things, assumptions are different. There are things that you are used to that they are being done differently. So I'm curious to learn about maybe some of the insights you got transitioning from personal to production, things that they are doing that you are not expecting to be doing, and maybe things that might even contradict what you thought was how things should be done and why, things like that.
Yeah, I'd say the biggest thing for me, the hardest part was learning that what I'd say is I'd say the reviews were the hardest part. Like learning that because you know something does not really mean you know something. So you might know something, but then you don't know. I don't know how to explain it. It's just that what I'd say, the thing that I didn't expect first was brute feedback. Because you see, where I was coming from, like this is like a little secret, but it's not really a secret. I didn't even have Linux. Like me, I was a Windows person. Like my laptop wasn't even running Ubuntu, Fedora. No, like the day I got accepted to Autrich, it was the first day. No, when I started my contributions in October, was the first time I got a VM, put Ubuntu there, and started to know this is what it means. So I didn't know anything about Linux. And so when I got in, I didn't know how hard it would be to get my contribution to the mainline kernel. So the feedback, like that aspect that I mentioned before, how people were really candid, it was very shocking for me, to be honest. I was like, oh, someone can tell me, you know, I used to read, now there's the media subsystem, and then there's like the main kernel, so like where Linus responds, like you could see things then you're like like you're really shocked. You should just go and check like whatever. So that was very shocking. But now, as I said, the thing that I learned there is separating feedback from work, because these people had nothing harmed, like no harms on you, it's just that your work is bad. And so the thing that was difficult for me in terms of my work being bad was I was overcomplicating things. I was not writing simple code. So that's one thing that my mentor kept pointing over and over again. Shout out to my mentor, he's called Hans. So the thing, and I remember when I started my internship, he did a presentation to me on what I should watch out for, and he just wrote there, be simple. And I was like, why would you tell me to be simple? And then I saw what it meant. Because you see, when you're working on the kernel, you have to be like doing bit masking, you have to do those bitwise, and you know the things you learn theoretically, and then to do you do what. So for me to do those things, I was doing like 3 if statements, and then Hans would review my code and he's like, this can be 1, like why are you doing that? So, and I'm like, yeah, okay, that's true, if I just put this there, you know. So being able to write simple code was something that I was not ready for. Like I didn't know, I was not doing that. The other thing that was a bit difficult is compiling the kernel. Yeah, that one was difficult because when I started doing that, also the thing that I didn't expect is sometimes it takes long, and because every time you make a change to the kernel, for you to be able to see the change that you have done, you have to compile the kernel. So like, can you imagine, like every time you do a change on Windows, you have to build Windows, compile, everything that makes of Windows, you have to build it again. But the first time it normally takes long. Okay, it took long for me because my computer was bad, so it took like 2 days. I don't know. It took long. But then after every, so now you have the most recent version of the kernel, but now after every small change, you just have to compile, which takes a bit shorter. So maybe 5 minutes, depending on the changes that you're doing and where it's touching, so that you can see if it's affecting other thing. The other thing I was not prepared for was debugging. You know, the kind of debugging. I'm telling you, I was used to Visual Studio. You know, Visual Studio will tell you it is here. Okay? Because you see, we are using Vim, like there's no user interface, there's no okay, you can use those things, but now what I was using at that time, there was no user interface. Okay, just like text-based, like not Vim, those things, right? So what's happening is you could get an error, and then it's telling you like this memory address has an issue, and you're like, no, what type of error is this? So the thing, so like the type of errors in the kernel are unique errors because it's either memory leak or it's deadlocks. Deadlocks, I was not prepared for that because you see, the thing about memory leaks, it's easy for you to find them. Deadlocks, it's difficult because what happens is that your program just shuts down, like an evil, and the log is not comprehensive enough. You need someone like Hans, who was my mentor. I used to send him the debug messages, and then he'd tell me, check this function. And then now, after some time now, I started to learn how to debug that because it was difficult. For those who don't know what a deadlock is, how modern computers, they have multi-threading capabilities. Like multi-threading is like the way right now, maybe you have different processes happen, not processes really, but different things happening in your computer at the same time. Sometimes they need to access resources, like they need to access something, both things. So when you write your code, you have to always factor in what if the two things want to access the same thing at the same time. It might corrupt the data, like it may change, both of them may change something that they were not meant to change. And so once that happens, the program hangs because it's confused. What are you doing? So I'd say those two things, like, no, I don't know if I said 2 or 3. The feedback, debugging, and writing clean code. Those were hard things for me to learn. Yeah.
And by the way, also another thing, sorry, Clement, just to chip in, we are actually setting up a session called Blackboard Workshops. We have actually one workshop set up where Dorcas will take us through just kernel development in a nutshell, like 2 or 3 sessions. So if you're really interested in that, you plug in. We'll be able to send that notification once we are ready. I think we had scheduled around September, right? Yeah, it's actually coming next month. So looking forward to that. Yeah, back to you, Clement.
I think that's also very very insightful response. Maybe another thing I'll be curious about is how you do testing in the kernel.
Testing. The deadlock test for you. When you compile it, like you compile the kernel and it does not compile, you just know your code is bad because you testing in terms of when you put a feature. I don't know, here, like on the front end side, like you have, I don't know, integration testing, unit tests, those things. I don't remember writing a test to mock the data because there's nothing you're mocking, because it's like, let me explain what I was doing so that it makes sense. So in the CSS system, what I was working on HDMI. So anytime you use HDMI, yes. So what was happening, HDMI is a protocol, right? I don't want to. So HDMI is like how data is sent. So it's for video and audio. So there are some devices that we have HDMI input and HDMI output. Laptops normally have HDMI output. In terms of HDMI port is labeled in how the data is sent. So from the laptop, the signal that is sent is HDMI output. So your TV would be HDMI input, because how the signal is going in is like an HDMI input. So I was working on a test driver. So a test driver is, we have hardware. So we have your laptop, we have your TV, and no, let's say your laptop, you have laptop and we have software, Zoom, something like Zoom. Now, if you ever wonder, how does Zoom, when you open Zoom, how does it know you have these cameras attached, you have these microphones installed? In between Zoom and hardware, there's something called drivers. So drivers are like the intermediary between software and hardware. They're able to detect like what type of software is connected to what type of hardware. Rather, no, drivers help hardware to connect to software. Like they tell software, this is what this hardware looks like. Now, between drivers and your app Zoom, sometimes you have an app Zoom, you know that it's going to be used. No, you have a camera, like a physical camera that maybe you want to use it as a webcam. You need to write a driver that is able to program the camera to speak to an app like Zoom. But then you can say that, and then now you have like the app Zoom. But let's say your driver code is not ready. But what is ready is your application, Zoom, is ready. So if you want to see, if I connect Zoom to, so there's a specific API that determines how every camera on the Linux kernel should look like. Okay, so there's a specific API that defines that. So what happens is, so when you're building your driver code, you have to follow that API so that you can be able to integrate. So if you already have your software, but then you don't know if your software is going to be able to integrate well with the cameras connected, you need a test driver. So a test driver is now an emulation of what would, if like your camera, if your physical camera and if your physical camera has correct driver code, will it be able to connect to my application? So if you have Zoom and you have a test driver, you can be able to know, this Zoom that I've made, can I be able to connect to any camera in any laptop? Because there's no way you can test all cameras, you see, and that's why we also have a specification. So now what I was working on was in the test driver side. Now, the thing that was happening was that we were now trying to emulate a physical HDMI thing, like a HDMI hub. So how that HDMI was structured was that we have multiple inputs and multiple outputs in the hardware. Like when you have a dock, you have multiple inputs and multiple outputs. And when you plug to HDMI 1, you can pull out your signal from HDMI input 1, you can pull out your signal from HDMI output 1. That's how it's matched, right? But then the driver was not emulating that. Like you could not plug anywhere and pull anywhere. So when someone was testing applications using our test driver, we were not like that. So that's what I was working on. And so testing is just how do I put it? So because now you're emulating hardware, and there's an API that has specified that this hardware is supposed to look, rather that driver code that speaks to whatever is supposed to look like this, you just now try to emulate that. And I'd say the best way to know if something works or not, if the kernel breaks, that thing does not. Like me, I don't remember writing tests. Maybe the tests were written kitambo, because you see it has been maintained for a long time, but I don't remember writing tests. It was just like when you compile the kernel, and the kernel compiles without any errors, and then you test the whatever the emulation that you have, and it works, that means that code is good to go, because there was like some sort of governing API. But I didn't write like unit tests, I didn't write like all those things, because it was just like, if it fails, you'll have a memory leak. If it fails, you have a deadlock. If it fails, you will just see those things there, and then now you know how to resolve. I honestly don't remember writing a test, but maybe the because that API has been, so the API is called Video for Linux because we deal with Video for Linux. So Video for Linux for L2 version 2, Video for Linux version 2 API. So yes, I don't remember doing test, Clement. So
Nice. All right. Sounds good. I see we are right over time, but it was awesome. But just maybe to close up, I think you've really covered everything that you, because we wanted you to share tips for anyone really interested in this, and just to open up like people's imagination, especially even this can be really good for folks who are in school, like you're wondering like what are some areas that I can venture in. I think when you understand how the low level of things work, I think even you become a better application developer. I have that philosophy. I believe that because you'll be able to reason every time you see things, you'll be reasoning on how the computer thinks versus how the users think. So that's really awesome. So whether you want to get into this like for real, or you just want for hobby, I think it is a good adventure to get into. So normally we close on by maybe just your top 5 tools as we close that you use every day. We call them the EDCs, everyday carries. What are those things that you can't do without? Maybe mixing up with when you're doing the kernel stuff. Yeah.
like developer things, because I'm a like
Plus any other thing.
Developer things that I can't do without, I'd say Vim. Well, I use Vim a lot. Like I thought I'd stopped in the kernel, but nowadays I just find myself like if I'm checking out something, like let me just open that.
It's Vim.
So, Vim, if you get into kernel development mode to respond to emails, now I'd say Git, but now because if you're doing any commit, you have to use Git. Then what other things? I my headphones, because I really like music, so anytime I'm bored I just listen to music. Yes, I guess those 4, because those are the things that I like, I use every day.
And you, of course, your own device now.
Yes, my laptop.
Okay, nice. So thanks so much, Dorcas. I know you will be coming back to get into like the workshop where we open the terminals. We start off like I'm looking into a session where we'll just start from scratch and then just build up to doing a dummy patch, and then maybe get guys joining the Linux kernel newbies mailing list. But I don't know if it's active. I joined, but I've not seen any email come.
No, it's not very active. Or the other, I remembered what I wanted to say. Another way to start contributing is some of the subsystems normally have volunteer projects, so you could volunteer to do a project. So if you check that subsystem, you'd see there's a place called projects. But kernel newbies mentions that even the Git contributions page, like I'm seeing kernel, but this is kernel. Or if you've ever wanted to contribute to Git, like the actual, not GitHub, because GitHub is separately on, but like the thing Git, same thing. They also have same things that you can be able to find.
Okay, nice. So I know you will delve into that more during the workshop. So I'm looking forward to that. Yeah, thanks so much for those who joined. I think we had a good number of people joining on LinkedIn and YouTube. So please remember to subscribe, like, share, and send the message out. And looking forward to more Linux kernel developers in the near future. Thanks so much and have a good night. All right, bye. Thanks.